This is the second part of the section 5.2 video lecture. So in the last one, we had finished talking about how we calculate the probability of event 1 or event 2 if the events are disjoint, meaning that they have no outcomes in common. But what happens if the events are non-disjoint? And that means they do have outcomes in common. Well, the process then is just a little bit different. Why? Well, let's go back to our Venn diagram. So if we have event E and we have event F, remember the piece where they overlap is the outcomes they have in common. So we'll call this event E, event F. So if we use the same formula we used before, which is the probability of E or F equals the probability of E plus the probability of F, we encounter a problem. And we encounter the problem because when we do the probability of E, that's everything that I'm shading yellow right now. Not that I can stay in the lines, but... And when we do the probability of F, it's everything that I'm shading blue right now. So what do you notice about the Venn diagram? We have this whole area right here in the middle, this green area, that we counted towards the probability when we found E, and we counted it again when we did the probability of F. So that anything in the overlap or any outcomes they had in common, we counted twice, which we don't want to do. So that overlap is what we call E and F. This little upside down U symbol is an intersection symbol, and it just means where the two things overlap. So we have to subtract off the intersection. And in words, we say that would be the probability of E and F. So just to be clear here, let's make a little key. If it's highlighted in yellow, that's event E. If it's highlighted in blue, that's event F. And the things that are green the part of the diagram that's green is what we call E and F. So how does this work? So what's the probability of randomly selecting a jack or a diamond from a standard 52 card deck? So we have the probability of jack or diamond. So by the formula, because these are non-disjoint, so they do have an outcome in common, and that is one card, which is the Jack of Diamonds. So we need the probability of getting a Jack plus the probability of getting a diamond. And we have to subtract the probability of getting the Jack of Diamonds, because we counted the Jack of Diamonds once when we did the Jacks and once when we did the Diamonds. So there are 4 Jacks in the deck out of 52 total cards. We're going to add, there are 13 diamonds out of 52 cards. If you need to, you can go back and look at the deck of cards in the notes. And we're going to subtract the common outcomes, which is the 1 Jack that is the Jack of Diamonds. So minus 1 over 52. So again, we can put that in the calculator. So we would just type sorry, I can't see. 4 divided by 52 plus 13 divided by 52 minus 1 divided by 52. And you can hit the math key and enter twice if you want a fraction. So we get 4/13 or approximately 0.318. So this is 3/18. Sorry, that should be 4/13. I just transposed all the numbers in my head. 4/13 or approximately 0.308. Okay, so now that we've done the probability of the cards, let's go to this contingency table, as they call them. So what is the probability of selecting someone who is 45 to 54 years old? So I will say the probability of 45 to 54 age. This is a simple probability. We are just looking at the total number of people that are in that age group. So the way we find the probability is we take the total number of people in that age group and we divide it by the total number of people, which is always found down here in this corner. That's the total number of people in the survey, always. Sometimes they don't add these up for you and you have to do them yourself. So that is approximately 0.264. Okay, what's the probability of randomly selecting someone who does not use social media? So does not use social media, that is these people. So we're going to say, I'm just going to say the probability of no SM for social media is the total number of people who do not use social media divided by the total number of people. And if you put that in the calculator, it's approximately 0.362. Okay. Now, what is the probability of selecting someone who is 45 to 54 years old and does not use social media? So, those people, we need the ones that are in both categories. So 45 to 54 is right here, and does not use social media is right here. So where the two overlap is just this 57. So we are going to do probability of 45 to 54 and no social media is 57 people out of a total of 530, which is approximately 0.108. Okay, I'm going to scroll up just a little. So now we want the probability of 45 to 54 or no social media use. Okay, I'm going to go back and erase what I've highlighted already. So let's look at that again. So the way we can do the OR from the contingency table, instead of using that formula that I showed you up above, is highlight the people in one category. So we need the 45 to 54-year-olds. So that's this column. We also need people that do not use social media. That is this row. And so just like with our Venn diagram, you can see that the outcomes they have in common are right here where our two colors overlapped, which makes sense because that's what we used in problem number 3 to find the probability of 45 to 54 and does not use social media. So now we say, okay, we've got the probability of 45 to 54 plus, that's the one category, plus the probability of they don't use social media. And then again, we have to subtract the part where they have outcomes in common. So that is what we call the probability of 45 to 54 and no social media. So if we put that in the calculator, we have 140 over 530, that's the probability of being 45 to 54, plus 192 over 530, which is the probability of not using social media. And then we're going to subtract off those 57 people that are in both of those categories so that we do not count them twice. And if you crunch the numbers on that, you come up with 275 out of 530, which is approximately 0.519. So that's the end of this section of 5.2. Sorry, with the second video for 5.2. We'll pick up again in another video.